The topic that was requested most was area between curves, disk method, shell method, cross-sectional area type problems. So let's take a look at some of these. This one here is from a practice exam. It is defining R as the region in between these curves. F of X is this one here. That one's F of X, and G of X is this guy up here. There's e to the X. And it tells us that we're going from their intersection point, which is at 0, up to the vertical line, x equals pi over 2. Part A wants an expression for the area of R. The area in between the two curves is going to be the integral from one intersection point to our other bound, which in this case is pi over 2, of the top function minus the bottom function, which in this case is g of x minus f of x. Easy enough. Part B. Part B is asking for the volume if we revolve about the x-axis. So because we're going about the x-axis here, we are going to use the disk method to find the volume of a disk. We want this here to be rotated about the x-axis. The volume of one disk is pi r squared h, where the radius is, so if we go all the way about the x-axis here, so the radius is this distance here, and the height of this disk is this little distance right there, which is delta x. So we are going to integrate from 0 to pi over 2 of pi times my radius. The radius is this distance, which is g of x squared. And then we need to take something out because we're going to be missing this space right here. We're going to need to subtract this part here out. So minus f of x squared dx. So again, for the disk method, what you're going to do is you're going to start at the axis of revolution, and you're going to go all the way across. That is your first radius. And then to figure out what the missing area is, or the missing volume, you're going to start at the axis of revolution and go to the first point, which in this case is f of x. Part C, we are doing the same thing, but let's go about the line y equals 2, 3, 4. Let's go y equals 5. And so we are revolving about this line right here. So again, we're going about a horizontal line, so we're going to use the disk method. Disk method is pi times the integral from 0 to pi over 2 of the radius squared. Again, we're going to have some missing volume in here, so we're going to do the first radius squared minus the second radius squared. So if I start at the axis of revolution and go all the way across, that radius there, this distance is 5, and then we need to take out this, which is f of x. We're going to do 5 minus f of x is going to be that radius. And then the radius of the empty space is this, which is 5 minus g of x. That is the disk method. Part D, let's revolve about the y-axis. So if we're going about the y-axis this time, now we're going about a vertical axis. So if I take this area here and revolve it about this y-axis. This is going to be the shell method, and the volume of one shell is 2 pi r h delta x. So we're revolving it this way. The radius is always going to be this distance. The height is this distance here. And then delta x is this small distance right there. So we've got 2 pi times the integral from 0 to pi over 2 of our radius. And in this case, our radius is just whatever the x value is. The height is the top function minus the bottom function, which is what? G of x minus f of x. And then there's our setup. Notice on all these, I'm just setting them up. You could use your calculator to actually find the volume. Part E. We'll go up to F. Let's revolve about the line x equals -2. So x equals -2 is right over here somewhere. Going about that. If I have our representative rectangle right here for the shell method, we've got 2 pi times the integral from 0 to pi over 2. Notice the radius changes. The radius is now, this is the x value, but then it's 2 more than that. So my radius is now x plus 2. But the height does not change. The height is still g minus f. If we were over here at maybe x equals +2, my radius in this case would be 2 minus x instead of x plus 2. And finally, part F says this region is the base of a solid whose cross sections perpendicular to the x-axis are semicircles with diameters in the xy plane. So if we cut this perpendicular to the x-axis, if I cut this right here, coming up out of the page this way is a semicircle. So this is lying right here. So this distance is this, which is g minus f. So the area of one of these semicircles is 1/2, because it's a semicircle, pi times the radius squared. Well, this distance is a diameter, so the radius would be half that. So let's go g of x minus f of x over 2. And then we need to add up all those, so we need to integrate from 0 to pi over 2 dx. If we happen to have one that said perpendicular to the y-axis, that wouldn't work on one like this, I guess. So that's if it is ever perpendicular to the y-axis, what we would do is we would solve for each of these. So it would be, like in this case, and let's suppose that sets square root of x. So it would be x equals y squared, and then this one x equals ln of y. And then it's going to be, you're going to do it the same way, but it's x value minus x value. So here we have y minus y. So it's going to be x minus x. And then your bounds are going to be the y values of the intersection points as well. Hopefully that makes a little bit of sense. I'd worry a lot more about the ones that are perpendicular to the x-axis as well as the disk and shell method.